All right, good morning. Um, I am continuing with this first chapter here in the Trigonometry and Precalculus course. Right, over here we're at angles and arcs, and I am reading through section 5.1. All right, now in angles and arcs, I'm at the relationship between degrees and radians. So I'm looking at the converting between degrees and radians, and this is familiar to me. I know that 360 degrees is 2 radians and 180 degrees is, 2 pi radians, and 180 degrees is pi radians. They're showing us that we have the circumference of the circle divided by radian here. Okay, so that's how we get the formula. That makes perfect sense. Okay, now dividing. All right, let's see. I paused for a moment. My daughter came in. Now, so here we are to convert between radians and degrees using the basic relationship that pi radians equals 100 degrees. Convert with pi over 100 or 180 or 180 over pi radians to convert. All right, so let me check that out for a second. And this is not something really that has to be memorized as an exact ratio. It has to be understood, and then it doesn't have to be memorized, right? So if I have pi and I want to convert it to degrees, I simply have to multiply it by 1. And these cross out, and we get 180, or vice versa. Yes, that is how it works. Right. Okay, good. All right, so if I had, though, this is interesting. Because if I had one radian, instead of having pi radians, and I multiplied that by 180 degrees, pi, then to get the degrees, I'd have to actually do that calculation, but it would still be accurate. So what is 180 divided by pi? 57.3-ish. So that would be 57.3 degrees. All right, so that was kind of like the important intellectual exercise to go through. See what happens when your radians don't actually come out to pi. That pi has to be calculated to a certain degree and then get an estimate of degrees to whatever decimal point you want. Okay, so angles that are fractions of a complete rotation are usually expressed in radian measure as fractional multiples of pi rather than as decimal approximations. Right. For example, we write half of pi rather than the decimal. Good. Very nice. I like that a lot. Converting degrees. Convert each angle in degrees to radians. All right, so I would multiply this one, the 30 degrees, by pi over 180. And so 30 over 180 would be 3 over 18, would be 1 over 6, would be pi over 6. Okay. So that'd be 1/6 pi or pi over 6. This would be, this is half of 180. So if we imagine that, we're really basically dealing with, when we're converting the other direction, pi is on top, 180 is on the bottom. So that the 90 and the 180 would combine to turn into 1/2 pi, pi over 2. And this negative 135, negative 135, huh? Well, that would be, okay, if we're going on the 5 times tables, we're talking about 3 less than 150. So 3 less than 5 times 30. So 5 times 27, right? Yes. 5 times 27. 27 over 36. Negative 27 over 36 pi. Let me see. They have, they don't just, not gonna, oh, haha, of course, 27 over 36 simplifies. Jeez, right? 27 divided by 9 is 3, and 36 divided by 9 is 4. So negative 3 over 4 pi. Oh, good. They told us the answers. The answers are right here, and I'm doing it correctly. All right. 27 over 36. All right. Checkpoint 2. All right. Convert each angle in degrees to radians. All right. So if I'm converting this to radians, which is what I did before. So how many 60s are there in 180? There are 3, so that's 1/3. So that's pi over 3, right? Oh, 270 is more than 180. So that's 90 more than 180. So that's like 1.5. That's like 1.5 pi. That means we would put probably in the fraction form, we probably put 3 over 2 pi for the fraction form. Is that what they're going to show us down here? For B? What? All right, so 180 degrees. Here, foreground and background. I like these checkpoints. If I have 270 degrees and I want to convert it to radians, that means I want the degrees to cancel out and I want the pi's to come to life. So pi's are going to be on top, 180 on the bottom. Okay, well, 270 divided by 180 is 1.5. Is it not? It is. Because that's 180. 180 plus 90 is 270. So that should be 1.5 over 2 pi. They're giving me this freaking negative answer over here. I mean, the way I can understand their negative answer is when we're looking at this angle here, 180 and then 270. 270 actually comes down here. It's another 90 degrees, so it goes all the way around. So if we were going to go the other direction, that would be a negative angle. That would be negative 90 degrees. Negative 90 degrees. Because 270 plus 90 then equals 360. Negative 90 degrees should give us like negative pi over 2, you would think. Because the 90 over 180 is 1/2. So why are they telling me negative 5 pi? Like, I'm agreeing with this first one, A. It's pi over 3. This is different. This is different. These are not the same. These are not matching to this. Okay, I'm reading it wrong. What? Why? So here they have example, checkpoint. So the example is not the same as the checkpoint. So this checkpoint here, I'm totally fine. They're just not giving me the answers to it underneath. Right? I'm fine. I believe I'm fine. Not really worried about it. Okay, the negative 300 over 180 would be 120 more than 180, right? So 180 plus 120 is 300. We're looking at one whole, and then 120 is 2/3 of that. So that's 3/3 and 2/3. Well, that gives us our 5. That gives us our negative 5 over 3. This one's C here. That gives us that. That's interesting. Negative 300 degrees is negative 5 over 3 radians. Weird. Oh, and they're showing us the negative 3 over here. Okay, good. Okay, good. Did we get the 270 down here somewhere? No. Okay, fine. All right, well, that's cool. And then, of course, I got to keep my pi there. Can't forget my pi. Negative 5 over 3 pi radians. All right, that's good. Good. Now, 1 radian is actually something I already did earlier, which I got like 57 degrees or something. Okay. Because if you think about 1 radian, it should be a little bit less than 1/3 of 180. Because if 180 is pi, but pi is 3.14, then a third of then it's a little bit less than a third of 3.14. 1 is less than a third of 3.14. So if I'm thinking 1 radian, how much of 180 degrees is that? It's got to be a little bit less than a third of 180. 180, a third of 180 is 60. A little bit less than a third of 60 would be like, 57 or something, 57 degrees or something. So when I went over here to the calculator before, right, I got 57.3. That's how I'm kind of remembering that and how it's making sense to me. 1 radian. And then 2.3 radians, there should be a little bit more than 90 degrees because 2 radians would be a little bit less. No, not 90. Why am I talking about 90? We're talking about 60 and 60. 120, 2-ish would be a little bit less than 120. So 2.3 would be more than 120, probably less than 130. Check it out. So that would be 180 divided by pi. 180. The pi's got to go away. The pi's got to be on the bottom. Times 2.3. Oh, 131 degrees. Okay, a little bit more than 130. So there we go. All right. So, okay, very good. So up here, I'm being flexible in my thinking. I'm thinking just that the pi part has to be on the denominator, has to go away when we're getting rid of the radians, and we're going to the degrees. And the 180 has to be multiplied, and then whatever the other factor is. Okay, so that gives us, right, 131.8, and I got 131.78, perfect. Okay, checkpoint 3. Convert each angle in radians to degrees. Okay, the radians here. So pi over 4. We want the pi to go away. So we put it on the denominator. And so we multiply by 180 over pi. And then we get 180 divided by 4, which is 45. So that's 45 degrees. Here, we want the pi to go away. And then we got the 180 times 180. So 180 divided by 3 is 60. And then 60 times 4 is 240, so we got negative 240 degrees there. See how that works? Right? I'm like, so when I'm looking at this, negative 4 pi over 3. I'm thinking we are bringing in the 180 degrees. Dun, dun, dun. So it's coming up on the numerator. Bringing degrees back, baby. Dun, dun, dun. And then we're going to get rid of the pi. Right? Pi, the radian pi's are going away. So that's, bam, they just cross out. Then I'm not going to multiply the 180 by 4 first because that's going to give me like a bigger number to work with in my head. It's easier just to see right away that 180 divided by 3 is, boom, 60. And then I'm just looking at 60 times negative 4. I'm like, 6 times 4 is 224. So I'm looking at negative 240 because there's the 0 in the 60. That's how I just like, boom, 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 see it in my head. And that's fun. Okay. So that's negative 240. 6 radians. Ooh, see, 6 radians is like almost 360 degrees, right? Because 3 radians is close to pi radians, which is 3.14. And that is 180 degrees. So we're looking at something close. But this is what we're gonna need. We're gonna need a calculator for this one. So we want to get rid of the pi. So I'm not gonna divide by pi in my head. So it's gonna be like 180 divided by pi times 6. And 343.7.8, right? Like I said, it was gonna be close. It was gonna be close to 360. So even though I'm using the calculator, I'm having a sense in my head of the ballpark of where the answer should be. Negative 4.7 radians. We got to get rid of the radians again. So we just like times negative 4.7. But still, we want to predict. 3.14 is 180 degrees. This is going to be like, negative 4.7 is pretty close to 1.5 3.14s. 1.5 threes is 4.5. 3 plus 1.5, 4.5. So we're looking at it's going to be something that's going to be close to like 180 plus 90 is 270. This should be close to negative 270 degrees. And it equals what? Enter. See, I said it should be close to negative 270 degrees. What is it? Negative 269.3. Like, hey, fun times. Loving it. Loving it. This is why I love math. Knowing your multiplication tables in your head makes math fun. You want to get really good at that. So I will create sources for that later. Let's see. Based on example 3, can I conclude that 1 radian is approximately 57 degrees? Yes. Six radians. Six radians is six radians. Go back to that. Times 6 gave us 43. That's almost 44. That's almost 344. So 360 minus 344 is 16. 16 divided by 6. 18 divided by 6. I don't know. Concluding that it's 57 degrees. That's interesting. Divided by 6 is 57. 3. Oh, interesting. Times 6. Because for it to really be 57 degrees, because it's a little bit more than that, that'd have to be like 360 minus 18, which would be which would be 342, but it's not 342, it's 343.8. But once you divide that by 6, it does round down to 57 degrees. Okay. Yes. Okay. Cool. Radians at 57 degrees. All right. Let's see. Drawing angles in standard position. Draw angles in standard position. Well, that's the next section. And I should go get ready for work and do other things. So I will end this video now. See you next time.